Hey everybody, this is Jared with Main Sequence Software, and today we're going to talk about plate solving. Plate solving is a very powerful feature in SG. It's fairly easy to set up, and once done, you really don't have to worry about it ever again. It can help you to get on track and recentered on, whenever you're doing the same target night after night, or even after a peer flip, it'll help you to get recentered and back and up in imaging. It's a really powerful feature. It's very easy to use. First things first, though, you're going to need to get and install Elbrus if you're going the Elbrus route. You can also use Pinpoint if you've already purchased Pinpoint. Pinpoint's fairly easy and straightforward to set up, so we're not actually going to go over that here. I'll be doing all the solving with Elbrus, so that's what this tutorial is going to focus on. So first things first, you need to get Elbrus. In the help documentation that comes with Sequence Generator Pro, at the very, very end of the documentation, there is a Elbrus setup section. It tells you where to go to download the tools that you're going to need. It tells where to get the databases and all that stuff. So go ahead and get that stuff set up if you haven't done that already. And when you're done, come back and we're going to talk about how to actually use Elbrus to plate solve. Okay, so once you're able to get Elbrus installed, we need to test it and make sure it's working successfully. So go ahead and select the Elbrus interface down here for the plate solve, and for the reference image I'm going to supply this monkey head reference. It's already plate solved, it has all the correct values in here, so it's a good way to test out your plate solving system and make sure it's working. Go ahead and select 5x5 with dual angle if it's not already populated and hit the solve button. Should come back fairly quickly saying success. If it doesn't, or if it takes a while, then it's likely that something went wrong with the installation. If that's the case, with the installation, or some of your values are set up incorrectly. If that's the case, please jump on the Sequence Generator, or the Main Sequence Software Yahoo group. Feel free to ask there. We'll be more than happy to help getting your plate solve set up. It's pretty easy once you get it going. Okay, so it's good that we can solve references, but now we actually need to worry about setting up the scope side for your night after night solving. The main thing that we need to worry about here is the scale. The easiest way to figure out what the scale is to just calculate it. There's a lot of websites that can calculate this for you. I use this one at wilmsloastro.com. I'm not really sure how to say that. Anyways, it's just a CCD arc second per pixel and focal ratio down here. And you just enter the focal length of your scope. I'm going to be calculating this for an AP130, so the focal length of that scope is 819. If it doesn't, if the manufacturer doesn't actually tell you what the focal length is, you can calculate that by the scope. It's 130 millimeter and it's a f6.3, so 130 times 6.3, that gives you 819. And then the CCD pixel size of my Qui9 is 5.4 microns, and I just want to do this for 1x1 binning here. And so I just calculate, and we get 1.36 arc seconds per pixel. I'm going to go back to SG, and for the 1x1 scale, I'm going to enter 1.36, and then whenever you click off of it, it's going to auto-populate the rest of these, so you don't have to worry about doing the calculations for each one of those. Over here for the for the exposure time, I usually use 5 seconds. That's generally adequate. If you're doing narrowband, you might want to bump this up to 10 or 20, but generally 5 seconds is even enough for narrowband. Now, the data on my Qui9 actually is flipped, and flipped probably needs a little bit more explanation here. So what flipped means is that the image is actually upside down on the camera. So here's an example of a normal image here. This lighthouse and whatnot, and the flipped representation of that image, it's upside down. So we have this issue because there's actually two different ways to store this data on your camera. You can store it in a bottom up or a top down representation. Neither of these are wrong, and different manufacturers do it different ways. On the Quai, the data is stored in a top down fashion, and I guess the norm for astronomy is bottom up. So whenever we read that data, what happens is it's flipped. And a lot of cameras do this. I don't know if one way or the other is more popular, but you'll notice if I rotate it, I actually can't get it back to this correct orientation, and that's because it's actually flipped in this x-axis, or in the y-axis here. So an easy way to tell if your camera is flipped is to take a picture of a terrestrial object. And if it's upside down and you can't get it so that it's the correct orientation, then you have a flipped image array on your camera. And whenever you're using Elbrus to plate solve, you're going to need to check this image is flipped checkbox here. And then from there, you just don't have to worry about it anymore. So now that we have the scale and we know what flipped means, it's time to get to solving. So for this demonstration, I've actually connected to the V2 simulator, and I'm going to use the telescope simulator as well. I've slewed the telescope simulator fairly close to these coordinates here. Actually, it might be very, very close to those coordinates here. And I'm going to, walk through solving. This is what the V2 simulator is returning. It's that same Monkey Head Nebula image that I used as a reference before. So for the search pattern, I don't actually know what my angle is. Well, I do because it's right over here, but assuming that this is a different night, let's say that I don't actually know what this angle is. So I'm going to use 2 by 2 degrees at any angle. What this will do is it'll allow Elbrus to chew on that data and rotate it through a full 360-degree rotation until it figures out the actual angle that your camera is mounted at relative to RA. So I'm going to go ahead and solve and sync. It'll probably take a couple of minutes because it does have to rotate that image all the way through. And before I do that, I'm going to change my exposure to 1 second. So we see it downloaded the image, and now it's plate solving that. Once this is done, we should see this get changed to a 5 by 5 degrees at dual angle, and this should also populate. It should also populate this angle field here. So any subsequent solve that we do after this initial one should be considerably faster. All right, so it comes back with the RA and deck. It also populates the angle, gives us a confidence. And now if we do another solve and sync, it should be much faster. So it's capturing that frame, and it's already solved it. So if you do the 2 by 2 degrees at any angle first, and then do all other solves at 5 by 5 with dual angle, you don't have to worry about figuring out what this angle is here, and you're just set up to solve for the rest of the night or until you move the angle of your camera. So once you have these values figured out, you're going to want to go through and update your profiles with those values. So same thing on the plate solve tab. You're going to want, depending on how you're set up, if you never move your camera, or if you pretty much have your camera attached to your telescope all the time, you can default this to the 5 by 5 with dual angle, and then just enter that angle in here, and then you're set up and ready to go. Enter your initial 1 by 1 scale here, populates everything else, enter any values that you want for your exposures, and if your image is flipped, make sure that's checked. Save your profile to update it, and you're ready to go. Next time you come through and you use the same profile, all this data will be here and ready to go. So now once you have all your scope data set up, it's time to actually start using this to get you where you want to go. So, generally you'll start out the night and you'll frame your target how you want. So maybe using the frame and focus module here. Once you get it framed to your liking, you can go through and use the solve and sync function. That's going to solve the image for you, and it's going to sync your telescope to the location that it's solved for. Now you also have this option here to use these results as your reference image. So right now we don't actually have anything in the reference, and even if we did, this would overwrite whatever was there. So checking this checkbox and clicking OK populates all the reference data now. So what this has done is whenever you use the scope centering, say you do a peer flip. After that peer flip, you use the scope centering. It's going to solve the reference frame if it's not already solved. It's going to take an image and sync to your current location. It'll then slew to your reference frame, and then it'll take another image after the slew is complete to validate that to validate how much error your the solvent or the centering had in it. Excuse me. So for here, since I'm using the simulator, I obviously have 0 error since the reference image was the exact same one that I used for my my camera. However, if you have a large amount of error, you can click Run Again, and that'll rerun the entire scope centering function. It'll take another image, sync your scope to that location, slew to your reference, and then redo the validation. So usually by running this 2 times, you can get your total pixel error very low. For my setup, I usually stop around 50 pixels. Usually I'm much lower than that. Usually it's about 17 pixels, but about 50 or so is still acceptable. So I hope that helps to demystify how to use plate solving in Sequence Generator Pro. If you have any questions, please visit us at our Yahoo group site, which is Main Sequence Software. Also check us out on the web at www.mainsequencesoftware.com. Thanks, and clear skies.